This is the video going over how to do the TI-84 button pushing to find a histogram, and then also to help us find the statistics in terms of finding the measures of center, like the mean and the median, and the measures of spread, like standard deviation and IQR. So going over this video should help you when you're trying one of the, I think, Delta Math links, where it asks you to interpret calculator output. So that should help you if you go over this video to make sure you're ready for that. So we have this first question, which says we have a survey in an intro stats class in college where students are asked to put the number of credit hours they're taking for that quarter. So it has 16 students, and you can see anywhere from 10 credit hours all the way up to 22 credit hours. Now, traditionally, if you're taking 5 courses in college at 3 credit hours a course, 15 hours usually is what most students will take, plus or minus a few. Most schools, I think you have to have 12 hours to be considered a full-time student, but I have to check on that. It's been a while since I was a full-time student. And then obviously if you have like labs, different things like that, they'll tack on an hour. I had, marching band and symphonic band, winds, orchestra, all that kind of stuff. That will add on a couple hours as well. So when you're a freshman next year, probably something around 15. Okay, so it says sketch a histogram. So the first thing I'm going to do is take out my 84, and I'm going to type in all of these into a new list. So I'm going to go to stat and edit. And I'm just going to type them into list 1. So I have 10. Let's just type in with my, there we go. So 10, enter, 2 of them. Then we have 112, 14. We have 4 students taking 15 hours. So you need to do 4 of these. Don't forget to hit enter after each one. Okay, 1 more. And then I have 2 students taking 17 hours. 1 student taking 19. 4 students taking 20 hours, and that's a lot of hours. And then finally, the largest number of credit hours is 22. And hit enter. Okay, so now that I have them all in my list 1, to get the histogram, I'm going to first hit second and this y equals, which is stat plot. So hit second, this y equals, which will take you to these stat plots. Let's turn the first one on. So just hit enter on number 1. And I'm going to hit enter on, and then hit the down button. And now you want to tell it, okay, what kind of plot do you want to do? And the histogram is this one that's 3 over right there. That is the histogram. Hit enter. And then you can scroll down or hit enter after that. But at this point, you're ready. I do want to use list 1 and then hit graph. All right. Now you're not going to see it most likely. So what you want to do then is hit zoom and stat. And zoom stat is, I think, zoom 9. Confirm for you. There it is. Zoom stat is number 9. And then there is your histogram. So let's go ahead and make a quick little sketch of this histogram. All right, so we've got credit hours, and we're doing kind of like a mid-height bar, a lower bar, so just say lower bin, then the tallest one, then the same height as that other one. This one's a little taller than the one before. And then another smaller bin. Okay. Now, it doesn't ask you to do this, but I'm just going to talk about it since it is important. Every time you make a histogram, it's a good idea to think about how you would describe the shape, the center, and the spread. Right? That's the key thing that you want to be thinking about when you look at a histogram. So in terms of the shape, you're thinking like, does it look unimodal? That's like kind of one main hump. Does it look bimodal, 2 main humps? Is there any skewness? So if you have like a tail kind of going in one of the directions, or is it roughly symmetric? Things like that. So those words will help you describe the shape. The center, in this one, you don't really have any of the actual statistics yet. You might just say like the middle of the histogram looks to be around whatever value, but we're going to calculate some of these statistics where it's much easier than just to use either the mean or the median. And then after that, the range, the easiest way I've always tell students to do the range, especially if they give you the data, you can see the range is 12 credit hours, or you can say it's going from 10 to 22 credit hours. But again, once you have the statistics, you can use standard deviation or the interquartile range, which is that IQR. All right, but the key thing is when you do shape center spread, to make sure you always put it into context. So if I were describing this, the distribution here of this histogram, I would say the shape looks unimodal. I know some students are going to argue with this, but really bimodal is when you have two separate groups that are like kind of separated almost by a gap. So this I still think is unimodal. I don't really know if it's roughly symmetric because you've got, so the first bin looks to be medium height, and then you have another pretty large bin to the right. So I'm not sure what to say about that. I don't know, but I don't see any skewness necessarily. For the middle of it, it looks like the median is going to be somewhere around 15, 16, 17. And then for the range, as I mentioned, going from 10 credit hours to 12 credit hours. So let's go back to the calculator to find letters B and C. We can calculate those statistics. So if I go to the calculator and I go to stat, back to stat again, that button for stat. But this time I want to go over to calc. All right, and this is where I want to calculate one variable statistic. So we only have one variable here. It is a quantitative variable for credit hours. Remember, we have a unit, hours. So I'm going to hit one variable stats. That's number one. Everything is in list one. So just hit enter. Don't worry about frequency list. We'll get to that at the end of the semester. And then calculate. All right. Now, a couple of things I want to point out to you as you've been reading in the textbook. You know that I am going to be using Y bar for my sample mean. All right. So in this case, where you see X bar in the calculator, I'm going to write Y bar. So the mean, which I'm going to write as Y bar. All right. I'm not upset if you write X bar, that's fine. The AP exam will have that too. The reason I use Y bar is because if you take any upper level math or stats in college, it'll help you kind of transition to those things by using Y bar. But it's your choice if you want to use X bar. So 16.3 credit hours. All right. For the standard deviation, and this can be pretty tough to understand, but I use just a lowercase letter s. All right. And when you're looking at for the calculator output, you want to use the SX for standard deviation. So SX is standard deviation, so 3.7 credit hours. And then I'll come back in a moment to standard deviation and try to explain that for you. The median, remember that's the middle number. You could have found that they actually have it in order here. I can show you real fast how to find the median. So we're just crossing out until we get to the middle number, which is those two are my middle, 15 and 17. And remember, if you have an even number of data values to find the median, you're going to take those two that are in the middle and you're going to add them together and find the mean. So 15 plus 17 obviously is going to give you 32. Divided by 2 is 16. So that's why the median is 16 hours. Let me scroll down and show you where that is. All right, right there you can see MED for median is 16 hours. And then the interquartile range, which is going to be quartile 3 minus quartile 1. All right, so that's going to be 20 minus 14 and a half. All right, that's going to give me 5.5 hours. Now, let me go back to standard deviation, then I'll talk a little bit about the quartiles. So standard deviation, the way that I've always talked about standard deviation is if we have the average, right, and the average number of credit hours is 16.3 hours. So if I erase all this again, so you can look at these credit hours, the actual data values, the individual students' hours, all right, what the standard deviation tells us is the average distance from our data values to the mean, right? So if you look at like a student with 10 credit hours or 22 credit hours, those are pretty far away from the average, okay? But if you look at a student that has like 15 or 17 credit hours, they're really close. So what it does is it finds the average distance of your data values to the mean. So really what I need you to know is that if you see a small standard deviation, that means that all of your data values are pretty close to the mean. If you see a larger standard deviation, that means your data values are more spread out farther away on average from the mean. Okay, and we could do, I know there's a video out there you can watch doing standard deviation by hand. If you want to do it in class, we can. You'll never have to find standard deviation by hand. Okay, let's talk about, I think you're good on the median, right? That's just the middle number when you line all your numbers up in numerical order. The quartiles, right? If I go back to these data values here, and why don't I do this? Why don't I put them out so it's a little simpler to see? There's 4 15s, 17, 17, 119, 4 20s, and then a 22. So again, we found the median, right? We crossed out. Crossed out. I'm not going to cross them out, just I'm going to show you kind of how this works. But you can see that the middle number is right here, right? That's the median right there. All right. I mentioned in a previous video that the median is the same as quartile 2. No one ever calls it that, but that is quartile 2. Now, what is going to happen to find the first quartile is now you find the median of the first half of data. So if this splits your data in half, like your median splits it in half, then if you look at the lower half, let's do the same thing. So for this one, we have between 14 and 15. So right here, hold on, which as you saw, quartile 1, right? So that's the median of the lower half of data. Quartile 1 was 14 and a half hours. So that's how they got 14 and a half. Same thing up here. If I do the upper half of data, the median is from the upper half is quartile 3, which is in between the same two numbers. And when it's in between the same two numbers, then that is just your quartile 3 or whatever median. So this is the median of the upper half, which is the third quartile. So again, as I mentioned, right, this is quartile 2. We just never call it that. So that's why quartile 3 was 20. The reason that it's important to kind of understand all these is the linkage that is important for when you describe the shape of this histogram. And you'll hear me say this a ton. If the shape of your histogram is unimodal and roughly symmetric, then it's okay to use the mean and the standard deviation to describe the center and the spread. But if your shape is not unimodal and roughly symmetric, like if it shows any skewness, or if it's binomial, or if it's got some gaps, right? If you've got potential outliers, then you would use median and IQR to describe the center and the spread. And we'll get to that a little bit, as we do chapter 4 and 5, you'll get more practice with that. So letter D kind of leads into what I'm talking about. Is it more appropriate to use the mean and standard deviation or the median and IQR to summarize this data? This is up to you. As I said, when I looked at this, it looks unimodal. I don't really see any skewness. So I'd be okay if you said that it's all right to use mean and standard deviation. I don't know. I don't know how I feel about this. I would probably take both answers. But the key thing for you to know is that whatever you choose, the linkage needs to be correct. So if you're saying mean and standard deviation because the shape is unimodal and roughly symmetric. So I just need your linkage to be correct. And so if you don't agree with this, then you're using median and IQR. Again, I'd probably take both in this scenario. Okay, let's do number 2 to kind of finish this up. It says, suppose we have 22 credit hours. That 22 is actually a 28. Oh my goodness, that student is taking so many credit hours. All right, what would happen if you were to change that number to be a 28? Now, we'll go in, I'll take the time, a minute or two to show you what happens when you change that 22 to 28. But hopefully, if you've been reading the textbook and been following with some of the videos, you should know that median is more resistant to potential outliers or data values that are far in either direction away from the middle. So when it says what's going to happen to the mean, if that highest number 22 increases to 22 to 28, that's going to take the mean and also increase it. I'm not sure about how much, but I'm pretty confident it's going to increase. The median, it could go up, right, depending on the number of data values, right? It could change, but it's just not going to change as much as the mean. So I'm going to put stays about the same for the median, you can easily calculate the range, right? We said the range was from 10 to 22 or 12. Now we're going from 10 to 28, so that's 18. That's obviously gone up, so that's going to increase. Should not surprise you if you increase your maximum. Just like the median, right? IQR, as you saw me when I went through how to find the quartiles, right? IQR is using the quartiles, and as you know, quartiles are just the medians of the bottom half or the top half of data. So really, IQR is using the same statistical idea as the median. So this should also stay about the same. Again, I want you to know it could change, but it just won't change nearly as much as the range. And then standard deviation, very similar to mean, right? I told you standard deviation is the average distance of your data values to the mean. Well, guys, if you change one of your data values to be farther away from the mean, then that's only going to increase the standard deviation. And if you watch that example of calculating the standard deviation by hand, you'll see that the mean is a part of that calculation. So if you make all of your data values, on average farther away, then it's only going to increase the standard deviation. All right, so that's it for this one. Oh, wait, I'm just kidding. Not it. That's not it. Let's show you what happens if I were to change it. So let's turn this back on. Uh-oh. Come on. Maybe I'm not going to show you. Let's try. Just push it. There we go. I am going to show you. So if I go to stat and edit, and I'm going to go down to the very last data value, which is 22, and I'm going to change that to be 28. Again, you don't need to do this when you take the quiz on Friday, but just want to show you to confirm if you were, if you were unsure. So change this to be 28, enter. Now watch what happens when I go to my graph. I'm going to zoom stat again, so zoom 9. You can see that bin far off to the right. We'll talk in chapter 5 how to calculate if that actually is an outlier or not. So for now, I'm just going to say it looks like 28 is a potential outlier. You can see it does look unimodal, but because of that gap to get to the potential outlier, that would urge me to then change my answer. Remember earlier I said I would use either one here for part D, but because now I've got that gap and potential outlier, I'm not going to use mean and standard deviation anymore. I think that 28 is, as we already mentioned, affecting the mean and standard deviation. So I would actually change my answer to be now median and IQR because I'm not seeing unimodal and roughly symmetric. Let's go to the calculations of our statistics. So same process here for list 1, but now it's going to calculate my new mean. So let me write these down and we can compare them. So my new mean is 16.7 hours. You'll see my median is the same. Go down here for a second. You'll see the median is still 16. You'll see quartile 1 is still the same. Quartile 3 is still the same. So you can see that my median and IQ are actually exactly the same. Standard deviation. So my new standard deviation is 4.5, which that went up from, I think it was, 3.7. So that went up almost an entire hour. And my mean went up a little bit from 16.3 to 16.7. So, and we already obviously knew the range. The new range is now 18 hours as opposed to 12 hours. So anyway, the point is, you don't need to do this, but it's just confirming for you what I said about that. Your median and IQR are more resistant, so they are going to resist being moved by potential outliers, but your mean and your range and your standard deviation will be impacted or affected more by those potential outliers. All right? Don't forget to try these practice problems.